Hi guys, I am Divyang from IGCSE Fingertips. Today we are going to discuss polymers, right? So what are polymers? Polymers are large molecules with small repeating molecules, right? So let's take one example. This is phenylethene, okay? It has a phenyl molecule with ethene, right? When this is repeated over and over, this is one phenyl molecule, but the double bond between the two carbon does not exist in the polymer, right? So this is one molecule, this is another, this is third, and there will be fourth, fifth, sixth, seventh. There may be 10,000 molecules of phenylethene. This polymer is known as polystyrene. How does it look? It looks like this, but we can't draw 10,000 molecules at one go, right? It's not possible, it's not logical. So what do? We show the monomer. We show the repeating unit and then we write N here. We show that this is repeated N number of times, which makes the polymer. And how do we show the monomer? We show that these molecules, they combine N times, 10,000 times, 20,000 times, whatever number of times, and they make this. This is the polymer. Let us see one more example what's happening. So we have tetrafluoroethene. Tetrafluoroethene, it has 4 fluorine, tetra, right? Double bond is there. Now this compound forms. So these are the carbon that were the monomer. How do you draw this monomer? Draw the exact compound, write N in front of it. How do you draw the polymer? Again, erase the double bond, give carbon one extra bond on each side because the double bond is broken, and write N here. This is the notation for polymer. Now that we know what are polymers, right? Large molecules made by repeating small molecules. Let us understand how are polymers made, right? Let us understand how are polymers made. Now polymers are made with two methods. First is addition polymer. Basically what we have seen in addition polymer, the double bond, right? The double bond will break. These double bonds will break and they will be able to accommodate one more ethene molecule, right? You can see here there was a double bond here just like this. It was broken and therefore this bond is possible. This bond can accommodate the next ethene molecule whose again double bond is broken. By these repeating units we make polymer. Because the monomer was ethene, polymer is known as polyethene, right? Some polymers have specific name, but mostly polymers are given name according to their monomers, right? So this is addition polymer. Now why is it known as addition polymer? Because you are adding something again and again and again. There is no other byproduct. The only product of this polymerization reaction is the polymer itself, nothing else. So this is addition polymerization. Now let's see what is the other type of polymerization. The other type is condensation polymerization, right? So what happens in condensation polymerization? As it is already marked, you can see H and OH are removed, right? H and OH are removed. They are condensed. Two different monomers are condensed together to form a polymer. So H and OH gives H2O. Water is lost from the cumulative molecule, right? OH from one, H from the other. Now if you notice, OH is lost by the acidic group. Let me erase this to show you. OH is lost by the acid group. What is this? This is COOH. We have done, this is known as carboxylic acid. This OH is lost by acid group. H is being lost by alcohol group. What is this? OH. OH on both sides, this is a diol. COOH on both sides, this is a dicarboxylic acid. Now what happens when water is lost? A bond is formed. C double bond O, OH, right? There is no H. In place of OH and H, the oxygen forms a bond with carbon, right? What is this known as? This specific bond is known as ester linkage, And terylene is an example of a polymer that forms with the help of ester linkage, right? Terylene is an example which forms with the ester linkage. So what are the monomers in terylene? There are 2 carboxylic acid on either side, and there are 2 alcohol on the either side of the other molecule. This is one example of condensation polymer. There is a very specific example that we have to study of condensation polymer, which is amide linkage, right? There are 2 main linkages that we study in polymerization. One is ester linkage, the other one is amide linkage. So how is amide linkage formed? In the last reaction we saw water is lost. In this reaction HCl is lost. Hydrogen is lost from NH2, right? If you observe, there is NH2 on both the side of this molecule, right? There is C double bond O Cl, right, on either side of this molecule. Now what is happening? The HCl is lost. As you can clearly see here, HCl is lost, and this N and carbon, they form the bond. NHC double bond O. What is this known as? This is known as amide linkage. NHC double bond O is known as amide linkage. This polymer is nylon. So by removing HCl for a monomer that has NH2 on both sides and another monomer that has C double bond OCl on both sides, removing HCl, the condensation polymer, condensation meaning something is removed, right? There is a byproduct. In the previous one, the byproduct was water. In this one, the byproduct is HCl. So when that is lost, a polymer is made which has amide linkage. This is an example of nylon polymer. Now we are going to understand proteins also, but just I want to make sure that you remember this, that even proteins have the same amide linkage. There's going to be a small difference in monomers, but proteins also have the same amide linkage. Okay, now we have examples of some natural polymers. The first natural polymer that we take is glucose. This is a glucose monomer, right? The name of the monomer is glucose. What does this box means? This box everywhere in all the examples that we have taken and the ones we are going to take means this is the non-reactive part. Okay, we don't need to focus actually what is meant by this box. I mean, what are the type of atoms present in this compound. We are just trying to focus on the atoms at the end, the molecules, the functional groups at the end, right? So what happens to glucose? In glucose, again H and OH are removed. So what kind of polymerization this will be? This will be condensation polymerization. Now it's not given, but this bond is known as glycosidic bond, right? This bond is known as glycosidic bond. Not in the syllabus, good to know, right? So what happens? A glucose molecule repeatedly forms a polymer with itself. It may form carbohydrate, it may form cellulose, depending on how the polymerization is taking place, right? We just need to know that glucose is a monomer, carbohydrates are a polymer, right? Now let us take an example of protein, right? Let's see what proteins are and how are they made. So in a protein molecule has carboxylic acid as well as amine group in the molecule itself. R represents rest of the molecule, which is not the reactive part for this chain, right? So we don't need to remember or even know what that molecule is. So let's say this is the first type of amino acid, right? The monomer of proteins are amino acids, right? So let's say this is first amino acid because the group is R in red. This is second amino acid because the group is yellow R, right? So the different color means different chain length, different type of compound. So what is happening from this side? H and OH are getting removed. What will be removed? Water molecule will be removed. So H and OH. OH from carboxylic acid, H from amine again. In the same way, on the other side, H and OH are again removed. So what's happening? In nylon, we had seen the amide linkage where the monomer had only COOH or NH2. But in this case, each monomer has a NH group and C double bond O group. This forms repeatedly, if you notice, this forms repeatedly, which is known as amide linkage. This is same as nylon. The amide linkage is same as nylon. Now, let us take up some questions so we can understand our topic better, right? Let us take up some questions. This was all for understanding what are polymers. Now we'll start with the questions and try to apply whatever we have learned until now. Ethanoic acid will react with an alcohol to form the ester shown. Okay, so let's just draw a circle around the part of ethanoic acid that is in this molecule. Name the other product formed when ethanoic acid reacts with an alcohol to make this ester. So ethanoic acid is reacting with this alcohol. What is removed? OH from ethanoic acid, H from the alcohol. So what is removed? They have asked, name the other product, right? So naming is water, writing the formula is H2O. Water is the perfect answer. Give one condition needed when ethanoic acid reacts with the alcohol to make this ester. Now we want to remove water. We must take a dehydrating agent. Sulfuric acid is a dehydrating agent, but to make it a dehydrating agent, we need to take concentrated sulfuric acid. Dilute sulfuric acid is a oxidizing or hydrolyzing agent. It will add water to the compound. Next question. Draw the structure of the alcohol which was added to ethanoic acid to make this ester. Show all of the atoms and all of the bonds. Now instead of drawing it here, let's draw it just beside this and then you can copy it down where the space is provided. So let's first draw all the carbon. We have hydrogen, 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 hydrogen and some more hydrogen. But on this carbon we'll write OH, right? This is what the alcohol is. Now they have not asked you the naming of alcohol, but I want you to tell me in the comment box below what is the name of this alcohol, right? Let's find the next question. Okay, so you have polyesters can be manufactured from carboxylic acid and alcohols. Hexane dioic acid has this structure, right? So what they have done? They have kept this chain of CH2 as a simple box because that is not the reactive part. That is how we understood polymers. This structure can be simplified, right? Ethane diol has similar structure, right? It has a chain of CH2, not as long, but it does. This structure can be simplified as shown like this. Okay, so this box is colored, this box is not, to also signify the chain is different, right? Okay, the functional groups are found at the end of the molecule. Yes, those are the reacting parts. Complete the diagram to show a section of polyester manufactured from hexane dioic acid and ethane diol. Include all of the atoms and all of the bond in the linkages. So what we shall do is we have to show how the ester forms. Now we have to remember that this empty box, right, the box that is not darkened, has a bond O only. But this box, right, as we can see here, this box contains carbon, right? So we'll have to show carbon on the gray box, right? Let me write a little bit smaller. Okay, so there is oxygen here, there is a carbon here, and the carbon has a double bond O. Don't forget to write the carbon here only, right? Double bond O, again oxygen, again bond, again bond, oxygen, carbon, double bond, O, bond, carbon, double bond, O, and a open bond to show that this chain is continuously repeated. Right? We have shown all the bonds and all the linkages. State the name of polyester. What will be the name of polyester? What are the monomers? The alcohol is ethane diol. Right? The acid is hexane dioic acid. So what will be the name of polymer? As we have done, the name of ester, right? The name of ester, first we name the alcohol and then we name the acid. So what is alcohol? Ethane. And what is the name of acid? The name of acid is hexane, right? Yes, it is hexane. But is this the name of polymer? No, we have to add something, right? The name will be ethyl hexanoate, right? We have ethyl hexanoate. Polyethyl hexanoate will be the correct name. So I'll add that poly. I've written it like this so you can name it easily. Polyethyl hexanoate. Right? It's a polymer. They are repeated. If there was one molecule of ethanol and one molecule of hexanoic acid, then we'll write ethyl hexanoate. But because it's a polymer, we'll write polyethyl hexanoate. Okay. Let's see. Which statement about nylon and terylene is correct? Okay. Terylene was an example of esterification. Nylon was our example of amide linkage. Okay. Nylon and terylene are made from monomers with C double bond C? No. Because both of them are condensation polymers. They contain the same linkage? No. Nylon is a polyester? No. Terylene is a polyester. Terylene is made from two different monomers? Yes. We saw the colors were different, which signified the monomers were different. Next, which diagram represents the structure of protein? Now, if you remember, we just did proteins in which there was amide linkage. But will this be correct protein? No. Why? Because on both sides you have C double bond O. Proteins are made from amino acids. Amino acids have a amine on one side, carboxylic acid on the other side. So we need to find another amide linkage, but must have amine and carboxylic acid on the same molecule. So your correct answer is option D, right? Okay. This is the part of question we have already discussed in our basics of organic chemistry. If you have not seen basics of organic chemistry, I will keep the link in the I button above. Check it out. So let's start. Compound A, it has these bonds and these functional groups, COOH. This is acid, alcohol and alkene, right? Compound A can be used as a single monomer to produce two different polymers. Draw one repeat unit of addition polymer formed from the compound. How does an addition polymer form? It forms when the double bonds are broken. So you have C bond C, right? First of all, this happens. Then you have COOH here, right? You have CH2OH here. You have hydrogen. You have hydrogen. And then this is continuously repeated. So let me draw one more on either side to show you that this is continuously repeated. See, you can also opt that you can draw it like this and then N, right? This will be your complete answer. I am trying to show you how will it look, right? So CH2OH and hydrogen here. The same thing on the other side, and I'm sorry, this is continued on either side, right? On both sides. Next, what type of condensation polymer formed from compound A? So if you form a condensation polymer what will form? The compound A itself has a carboxylic acid and an alcohol group. So the condensation polymer is going to be ester, right? It's going to be ester, right? Next question. There are two types of polymers, right? Addition are made from many identical small units. What is the term used to describe these small units? It's easy. They are known as monomers, right? Okay. A section of an addition polymer is shown. Draw the structure of small units used to make this addition polymer. Show all of the atoms and all of the bonds. It's very simple. So what do you do? Because it's an addition polymer, we have to identify where was the double bond. Now if you look at the compound, you can easily identify that this part is repeated again and again. So what you do, the simplest thing you do is draw this part like this. So you have H, H, CH3 and CH3. We have to do the opposite what we did when we were making polymers. Now we broke the bond in polymers to give these two bonds to this carbon. So we'll break these bonds and form a double bond between this carbon. This is the monomer and we have shown all the atoms and all of the bonds, right? Okay. Polyamides are condensation polymers. What does the term condensation mean when used to describe this type of polymer? So what does it mean? There is something removed, or I'll say there is more than one product, right? You can also write something is removed, but don't write what a molecule is removed, because we have seen two examples in which one of them HCl was removed, right? So don't write water is removed. The simplest way is there is more than one product forming. Okay. A polyamide can be made from two molecules. Okay. A simplified structure of 1,6-diaminohexane is shown. Complete the diagram to show section of polyamide manufactured from octane dioic acid and 1,6-diaminohexane. Sorry, include all of the atoms and all of the bond in the linkages. So this is empty box, which means it has NH on both sides. Now we have done this previously, understanding what the box means and what to draw. So let's just draw NH on both sides of the box, right? And let's draw C double bond O on either side of this dark box, right? This is amide linkage, right? Don't make the mistake of drawing C double bond O on one side and NH on the other side. That's the most common mistake seen in these type of questions. State the name of synthetic polyamide, right? Let's do this, guys. You tell me what will be the answer to this question. You already have the monomers. You already have the name of the monomers. Try to name this and let me know in the comment box below. Which brings us to the end of polymers. If you have any questions, suggestions or appreciation, please let us know in the comment box below. You can ask for more revision topics again in the comment box. Thank you.